Okay. This project, you're going to be teaching another method called variation of parameters. This is actually on our course topic list. It's something that we're supposed to cover in the course, and I cut it out in order to have time to do all these projects. So I figured the best way to like meet that threshold of saying, "Oh, we covered it," is have you guys cover it. So if you choose to do this, you're going to be teaching us a different method of solving non-homogeneous DEs. So you're actually going to be teaching the class. And what I would recommend, you can see here, I Googled variation of parameters, differential equations. Paul's online notes has a great write up here. You may want to go out and like maybe watch a couple YouTube videos, learn the math behind the method. This is the most important thing, is I want you to quickly derive this formula that we end up getting here. Don't just jump straight down here to go, okay, here's the method. I want to see the math behind it. I want to see why this works. Now remember, your whole presentation is only 10 to 15 minutes long. You absolutely cannot go over 15 minutes. Please don't ever do that to anyone. If you were presenting at a conference and they told you 15 minutes and you went 16, they'd never invite you back. Don't go over 15. So you want to quickly kind of go through all this math. You're going to have to skip some details. I understand that. You'll probably have to watch a couple of videos so that you understand what's going on. But get us to here by going through all that math up there. Just fill us in on the big details. Then you're going to do 3 examples, and these will go much quicker of using variation of parameters. So first, something we could easily do using undetermined coefficients. So remember, in your paper, you're going to have all these details. Your paper is going to have all those boring details that you may not talk about in the presentation. So you're going to solve this DE 2 different ways, using undetermined coefficients and then using variation of parameters. And undetermined coefficients is probably going to be easier. You get your homogeneous version, you solve that, get your characteristic polynomial, assume a particular solution, so forth. It's not too bad. Maybe discuss a little bit. In this particular case, it was easier to do this version versus that version. Then I want you to do two that would be very difficult using undetermined coefficients. Like, why do we need this other method? We've already got undetermined coefficients. This guy here would be really ugly. I would have to assume a solution that looks like tangent and secant squareds and all kinds of nasty stuff. This one would be ugly. This one might be impossible using undetermined coefficients. So these two you're just going to solve using variation of parameters. And right here are those solutions. That's why I picked these problems. So they're both here. Of course, you're going to type up all the details here. If they skip any steps here, you're going to type up those steps. But like here, we have most of the work done for you. So your main job is teaching the method. Okay, so in your paper, again, you're going to type all this up. I'll show you the best way to type up math. Then your presentation's 10 to 15 minutes long. You might spend 6 or 7 minutes just teaching us the method, going through the math up here, and then a couple of minutes each going through each of these examples. Remember, during the presentation, you're just hitting the highlights. The number one rule for doing a math presentation is do not read to your audience. I would say that's true for any kind of presentation. Never read to your audience. You should never have a big old giant block of text on the screen at the same time, depending on the person and the problem. Some will find the formula easier to memorize and use, while others will find the process used to get the formula easier. The examples in this section, oh my, you're already bored. Don't do that to your audience. You would never have this many words on the screen at once. Because even as I'm trying to talk now, some of you are trying to read what's going on here. You're not even listening to me. You're trying to read. Don't do that to your audience. Other times I'll have people who the slideshow will be fine, but you can hear them in the background. They've got note cards and you can tell they're just reading. So maybe this is all that's on the screen, but you hear the final quantity in the parentheses is nothing more than the complementary solution with C1 equals negative. It's so boring. Just talk. Know your material well enough that you can just talk. Whoever is presenting needs to be the one in control of the slideshow. If I'm the one talking, I need control of the mouse so that I can point to stuff. Never put a bunch of math on the screen at the same time. Like I would never have all of this math on one single slide. It's overwhelming to the audience. It's better to have multiple slides and don't read all the math to us. Okay, here's our second ordered non-homogeneous DE. Oh, like I don't want to go through all the details here, but solving for U1, we get this here. Solving for U2, we get this. Combining those together, we get our Wronskian here. And remember, the Wronskian can't be zero. So we end up with U1 is this integral and U2 is this integral. Again, you're going to go through the important facets of this, but don't read the math to us. U1 equals negative the integral of U2. Just say U1 is this and point to it with your mouse. Okay, so how are we going to type all this up? My recommendation to you, use Google Docs. And then you can share with everybody in the group. I recommend using this extension called Auto LaTeX Equations. Everybody in the class is probably an engineering major. You're going to need to learn LaTeX at some point anyways. Now's a good time to start. LaTeX and mathematical typing software. So you can see here they tell us all of my math needs to be enclosed in these dollar signs. So what was that first DE? I think it was y double prime minus 8y prime plus 15y equals, I don't remember what I had, but let's say it's 4e to the, and then I need to get up in my exponent here, I need to put these in braces, 2t, whatever I had there. I hit render, and it produces a nice, beautiful equation. Some of the stuff that you're going to type up in LaTeX, you're going to have to Google, how do I do fractions in LaTeX? It tells you right there, by the way, but you're gonna have to do a little learning. It's a learning process. So you're going to type everything up here. By the way, you don't have to hit render every time you type an equation. You could type 10 equations and then hit render and it'll render all 10 of them. Make sure each one is enclosed in dollar signs. If you goof, you just highlight it and go right to the beginning of it and hit derender. And then you can go in and edit it and then re-render it. So again, the paper is going to have all the boring details. The paper is, like you're going to say during the presentation, if you want to see all the details, go look at our paper where we typed all this out. Then the presentation, your slideshow, I recommend using Google Slides. Now listen, I know you guys like doing all these fancy presentations with all the backgrounds and the animations and the transitions. I'm going to tell you, I could not care less about that stuff. Your entire presentation could be white background with black text, and I'm perfectly happy. I don't care for all the fancy stuff. It's not, I don't think it adds anything. If you want to add all that fancy stuff in with the transitions and the backgrounds, feel free to, but I wouldn't spend a lot of time. You can type up math. It is possible to type math here, but I think it's a lot easier to over here in Google Docs, type up the entire paper and then just copy and paste the stuff you want in the slideshow over here. So I could highlight that equation, Control C, come over here, Control V, move it, resize it, boom, I'm done. So my recommendation, type up the whole paper first, then come in, create your slideshow. The entire group is responsible for the entire project. So you're going to figure out as a group how you want to divide up the work. Do not play this kind of game where you say, okay, my job is to do example two, and then that's all I'm going to look at. Example two was perfect, and I'm happy. Everybody's graded on the whole thing. If example three has mistakes in it, everybody's losing points. So, yeah, you may do the math for example two, but you got to double check everyone else's math as well. Don't read to your audience. I'm going to keep saying that because people still do it. Whoever's in control, whoever's speaking should be in control of the mouse so that you can point to stuff. Okay, I think that covers. I think that's a good place to stop.